Welcome back, guys and girls, to another fun-filled, action-packed, non-flipped Algebra 2 classroom video. Today, notes number 5, Unit 2, and it's going to be all about absolute value inequalities. So, an absolute value inequality graph is a shaded portion of the coordinate plane with a V-shaped boundary. We can see on these two examples, the graph is going to look like this. It's pretty much exactly an absolute value graph, except the important thing here is, one, the line is either dashed or solid, and there is a shaded section. All right, now the shaded region is important because it contains all the points x, y that make the inequality true. What does that even mean? What the heck does that mean? Well, watch this. If I pick a point from the shaded region, that's the yellow region here, let's pick this point right here. What is this point? This point is going to be 1, 3. All right, my x is the 1 and my 3 is the y. So watch, I'm going to put these values into my inequality right here. So the y value was 3, then I have the greater than sign, and then x, so absolute value of x, which is absolute value of 1. What is the absolute value of 1, guys? That's just 1. And we got 3 on the left side and greater than. Is 3 greater than 1? Yes, it is. It's true. And so that's what this shaded region is saying. Any point we pick from there is going to be true. And watch, let's do it, and let's just do one more to make sure. Let's go with this point right here now. What is this point right here? This point is going to be -2, 4. What's the x value? It's -2, and the y value is 4. So let's plug it in and see if it's true then. Okay, we got 4, and then greater than or equal to the absolute value of -2. What is the absolute value of -2, guys? That's just going to be +2. And 4 is greater than or equal to +2. Is that true? Yes, it is. So you can see the shaded region tells us that any point we pick from that region is going to make our inequality statement true. All right, so now looking at the equations for these two graphs, y is greater than absolute value of x and y is greater than or equal to absolute value of x. How can you tell if the boundary line is a dashed line or a solid line? What gives that away? So if you look at the sign right here, just greater than, and then we've got the greater than or equal to. When it's just greater than, it's going to be the dashed line. When it's greater than or equal to, it's a solid line. So let's write this down. Less than or greater than, it's going to be dashed line, which looks like this. And then when we have less than or equal to, or greater than or equal to, it's going to be a solid line, which is just, like a solid line. So write that down to let yourself know when you would have a dashed line and when you would have a solid line. Okay, now the other thing that we need to pay attention to is the shading. How do I know where it's going to be shaded? Take a look at these two examples right here. We've got y is less than or equal to the absolute value of x. You can see the graph right there. And then we've got y is greater than or equal to the absolute value of x right there. So one of these graphs is shaded below the v, and one of these graphs is shaded above the v. How do you know which one is above and which one's below? Well, this sign right here, that's the less than or equal to sign. Less than, if it's less than, which is like this, or we're going to do this one, both of those are less than, then we're going to shade below. Shade below. If it's greater than, like this sign right here, greater than, then we are going to, it's like this, or this one, then we're going to shade above. So now that we have that, let's do some examples right here. Based on the graph, they've given us the graph. We can see there are some transformations, but don't worry about that. We just want to write the correct inequality symbol based on the graph. So looking at this first one on the left here, my function is absolute value of x plus 1 minus 2. And what should my sign be? We can see that it's a dashed line, so we're either going to be using the less than or the greater than. And we can see that it is shaded below the v, which means we're going to be using less than. There we go. Looking at the second one, the middle picture, look at the boundary line. We can see that it's dashed, so that means we're going to use less than or greater than. And we can see it's shaded above the v, which means it's going to be greater than. Yes. And then finally, on the right side over here, we can see the boundary line is a solid line, which means we're going to be using less than or equal to or greater than or equal to. And it is shaded above the v. The v is upside down here, but it's still shaded above it, which means we're going to be using the greater than or equal to sign. All right, so let's try. We're going to graph these inequalities right here. So first off, we've got this one over here. Y plus 2 is greater than or equal to x. Wait a second, that's really weird because normally we have y on its own. So we want to get y by itself. What do I need to do here to get y by itself? I'm going to subtract 2 from both sides actually. Boom. Goodbye 2. And that's going to leave me with y is greater than or equal to the absolute value of x minus 2. Okay, so now we just need to graph this. We need to graph the absolute value of x minus 2 first. That is going to be the parent function of absolute value of x shifted down 2 units. So remember, I'll draw my parent function then shifted down 2 units. So my parent function looks like this. And now I'm going to shift it down 2 units. So I'm just going to pick some points and shift them down. Boom. Oh, geez Louise. Boom, 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 boom. So my new graph is going to look something like this, okay? And now we just need to take care of the shading. Now, notice I used a solid line. Why did I use a solid line? Because it's greater than or equal to. Okay, so now I just need to take care of the shading. Where am I going to shade? Am I going to shade above the V or below the V? We can see it's a greater than sign, so we're going to shade above the V. So up here, boom, and we did it. All right, looking at the next one, we've got y minus 5 is greater than the absolute value of x minus 3. So first, let's get y by itself. So let's add 5 to both sides. Boom, boom. That leaves me with y is greater than absolute value of x minus 3 plus 5. So first of all, let's take a look at the sign and make sure we know what kind of line we're using. This is greater than. I don't see the equals to, which means we're going to be using a dotted line. Okay? And then now we just need to take care of the transformation. So this is going to be, remember, let's go with we're always going to graph the parent function first because then we can just slide things over. So my parent function points, I'm just going to graph some of the parent function points here. We're going to have right here, parent function points for absolute value. And we can see that the negative 3 on the inside is going to move our points to the right 3. And then the plus 5 is going to move our points up 5. So watch, if I take one of my points, like right here, I'm going to go 1, 2, 3, over, and then up 5. 1, 2, 3, 4, 5. So that's where my new point is, right there. So I'm going to do that with each of my points. This is my starting point, so now, from the starting point, my other points would be like this. And now I'm just going to connect it, but I'm going to use a dotted dashed line like this. Alright, so we've now drawn our graph, but now we need to shade it. Are we going to shade above or below the V? It is greater than, so we're going to shade above the V, like this. And that's this one. On to the last graphing example. Alright, so this time we want to get y by itself once again. Let's get rid of the negative 4 by adding 4 to both sides. Plus 4, boom. And that leaves me with y is greater than or equal to the negative absolute value of x plus 1 plus 4. So I'm going to graph some parent function points. We're going to have like, remember, negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. What are the transformations that we have here? First, we've got reflection over the x-axis because the negative on the outside tells us that. So I'm going to flip all these points over the x-axis. So my new points are going to be over here. So let me erase these old points, okay? Still not done. Now I'm looking inside and I see that I've got this +1 right here on the inside. That tells me to shift all my points left 1 space. So I'm going to take all my points and shift them left 1 space. Boom, 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 boom. So let me erase those. I'm just going to be switching colors here to show my steps. And finally, I've got the +4 on the outside, which tells me to shift up 4 spaces. So I'm going to go up 4 spaces. 1, 2, 3, 4 right here. 1, 2, 3, 4. 1, 2, 3, 4 right here. Here, here, and here. So that is where my final points would be. And then I just need to connect it to draw my actual graph. But before I actually draw my graph in, let's make sure we know which type of line we're using, dashed or solid. We can see that this one is a greater than or equals to, which means it's a solid line. So we're good to go. I'm just drawing a normal solid line. And like this. All right, so now let's take a look and see if we're shading above or below. The sign is greater than or equal to, which means we'll be shading above. Greater than is above. So we shade up here, and we're done. That's it. So for the final problem here, it's asking us to recognize a couple of things. So first of all, look at this graph right here. Where is the vertex? The vertex is right here. It's the sharp point. So we need to identify that point. That's going to be at -2, 1. All right. Next one, has the graph been reflected? Yes, it has, because originally the absolute value function is a straight up v, but this one we can see it's an upside down v. So yes, it has been reflected. Okay, next, what is the slope of the branches? There's 2 branches, and so we're going to find 2 different slopes. All we have to do is pick 2 points and then go rise over run. So from here, it's up 1 over 1. So one of the slopes is just 1. And when we go into the other branch, it's down 1 over 1, which is -1. 1 over 1 or -1 over 1, which is just the same thing as 1 and -1. Okay, now are the branches dashed or solid? We just have to look at the picture. We can see that they are dashed. And then is it shaded above or below? And we can see the yellow region is above. And then finally, can you tell me the equation for the graph? Now, so let's work our way. And finally, we need to write the equation for the graph. Okay, so we're going to start with the parent function. So let's leave some space though. The parent function is going to be y equals, and let's leave space just in case we need to add things. So we got the absolute value of x, and let's just close it over here, just in case we need to move things. Okay, so we can see that it was reflected across the x-axis. That means I need a negative sign. Is my negative sign on the inside or the outside? Reflected across the x-axis means my negative side is on the outside. Okay, so now I don't need to worry about the negative sign on the inside, so I'm going to move the x over a little bit. Okay, then I can see that I moved to the left, because my original spot would be here. I moved to the left 2 spaces, which means on the inside I would write +2. Left is plus, remember, so +2. And then finally we can see that we moved up 1 space from the original, up 1 unit, which means I'm going to, on the outside, I'm going to write a +1. And then this is my equation, except we're not using an equal sign. What should we be using here? Let's erase the equal sign and now put in my actual inequality sign. What should it be? We can see that, first of all, we've got a dashed line, so we're going to be using either less than or greater than. And we can now look at where it's shaded to let us know which sign to use. It's shaded above the V, which means we're going to be using the greater than sign, like this. And that is my inequality. And with that, that concludes our notes about absolute value inequalities. So until next time, see ya, peace!